So what you offer there brings us to, I believe, the core inquiry about the mystery of learning. We've had here in the house our granddaughter for her first ever sleepover with her grandparents yesterday, 20 months young. And first of all, I observe that she learns, she makes extraordinary leaps, sometime in a matter of days or weeks. Second of all, I observe that she knows and she is much more intelligent. Here is this word we're using again, intelligence. She is much more intelligent than she is actually able to translate in language as yet. And she seems to be able to assimilate with profound leaps. So I ask myself, what is a way to explain that this leaps, the leaping mind, the capacity of the mind to make such leaps? And I'm going to offer you 4 conjectural possible stories. I don't know which one is right, or whether it's a combination of any of the 4. But I think when you're describing the kind of challenges we are facing now, they more lean into this unresolved mystery. Okay. Conjectural story 1. Is it possible, could it be, that the toddler coming into this world already shows up with the entirety of the human experience and knowledge encoded to the brain, such that when they go through the experience, it innervates and activates, and they unlock what is already latent? I'm going to use this coarse language in this context. What is already wired into their hard drive in their brain. Conjecture story 1. Conjecture story 2 says, no, can't be in the brain, because so much of how the brain unfolds or develops is to do with these synaptic connections, making new connections. So it must be somewhere else. Let's imagine there is something we call a soul. Let's imagine that the soul is something that we can describe as an invisible loom of information. It's an information network. And that therefore, when the brain moves into different situations, it downloads from the soul that combination of knowledge and activates it in the brain. So that's conjecture story 2. Conjecture story 3 says, no, that entire knowledge exists somewhere, but not in her, not in her soul, not in her brain. It exists in the cloud. Use metaphor, technology metaphor terms. What's the cloud? The astral realm, the Akashic realms, some other realms where the collective knowledge, or what Jung will call collective unconscious, is lodged. And then every time she moves between different situations and instances, she downloads from the cloud and activates, exactly as my computer downloads the update of any of the software that's running. So that's conjectural story 3. Conjectural story 4 is more, I think, an interesting, intriguing, provocative direction that Alan is proposing for us, and I'm not sure exactly how to describe it, where it suggests that actually we think of ourselves as individual units, but we are not. We are a connected network. So for her, she's 20 months young, but she interacts with mommy and daddy and grandparents and other people around. Every time there is a social interaction, that some of the latent potential knowledge is actually locked in all these connections, and every connection brings online for her, activates for her something that exists in that latent collective knowledge. And that's how she makes the leaps, in which I think this is partly the suggestion you're making, Alan. We've been obsessed with individuality, with individual performance and all that, focusing on the individual person. You're saying now, in reframe, reverse the view, think about the human phenomena more through the social, communal, interpersonal lens, how as those evolve in their sophistication and capacity, that evolves intelligence. And that's how even when a toddler shows up in the world, they actually quickly trace through these layers of sophistication through social interaction. These are 4 conjectural stories. I have no idea, but my point is you are describing that technology or AI or whatever we have known as compute and is now seeking the Holy Grail. And if it is seeking the Holy Grail, it's going to be exploring these kind of inquiries. Which of these or another story would you be inclined to uphold?
Another story.
Okay.
I'm sorry. I almost like your last one, but no, because you then go away and talk about the society or the connectedness. Is the individual, the mind. The mind is really fascinating. And we need to frame the problem differently. Okay? Many people frame the problem like the way you describe it. Oh, I observe these kids and they learn very fast, phenomenal, and incredible. But really, the problem is not that. That can be explained actually quite easily without using any of the 4 conjecture. But the problem really is, if you think about it, I always think of, what the problem with AI is that we put the program and the knowledge and the task into the computer. It didn't learn. What do I mean by learn? Learn is not teaching many of the learning algorithms that we learned as an adult. We have many ways of teaching and learning, but it's not that. The amazing learning is this. The infant is born. It learns on its own. It sees the world and it starts to learn. So if you want to understand learning, we must ask, how can I create a computer program that, given the input and the sensors from the real world, without telling it what to do, can learn like the infant? I can't tell the program anything, and yet it can learn. That is amazing. Once you solve that, the learning very fast can be explained in this way. Infant learning of the physical world, what they learn are some rules guiding the behavior. So psychologists have, this comes from the psychologists, because I am no psychologist. So the psychologists observe that if you experiment the infant and make them observe things in the real world, and then you change that behavior, suddenly at some point they get excited because that was not expected. By that, it means that they have learned something. And the things they learn are not simple, not the kind of machine learning where we feed in a lot of data. This apple, this not apple, this orange is not orange. We're not learning like this. The thing we learn is, if there's a toy car that goes down a slope, okay, if you put a block here, it learns the notion of this is an obstacle of the path and it expects to stop. Now, if you simulate that and this car goes through the block, and the infant will get shocked. So they learn the notion of obstacle. They learn the notion of support. So if you put a pen like this, you let go, it should drop. And then if it didn't drop, it will shock. These things are not visible to the infant. Okay, it's not like the pen. The pen is visible. You can see the pen, you can see the apple. But these kind of rules, how could it form this rule without telling it? Now that is the amazing question. Now, if the infants, once they start, somehow got that trigger, then the mind will explode. And that's why they learn so fast, because they're capturing everything along that line. But how did we do that? Now, that to me is the real mystery of learning. So in AI research, I focus on three things: the language, the learning, and spatial connection. And it turns out after many years of learning, I realized I was lucky to start with spatial connection, because spatial connection is the simplest of all. Because why? Now with hindsight, I can explain that. You can see many animals and things from rats to humans, they all need spatial connection. We know that because we move around the environment, we need to know how to return back to our nest. Then come learning is the next important step, because without understanding how the world acts, we know nothing. So spatial connection, learning, and language, of course, is the most powerful, and that's why only we humans have language, because it's the most difficult. Okay, so in all three, once we learn what is happening in them, we will have unravel the mystery of the mind. Now, the problem with AI is the AI researchers don't pay attention to this mystery. Okay, so for example, in language, we have a famous paradox called Baker's paradox, whereby the infant, it was discovered by these psychologists and heavily debated among them, with notable scientists like Minsky and Pinger. And in brief, what is it that they recorded the infants listening to the words while they were very young, from birth to when they start to speak. And it was realized that when they start to speak, suddenly they generate and use grammatical structure that are not in the data. So how could they learn that if they're not in the data? And if they're all in the data, that's fine. I mean, we have many AI algorithms that could learn that once you're in the data, but it's not in the data. So where does it come from? So it leads to very famous researchers like, not Minsky, sorry, Chomsky, like Chomsky and Pinger, who claim that grammar must be innate, because there's no way to learn that from the data. So it must be innate. And so there's a huge debate whether grammar is innate or not innate. You see, but AI researchers look at the syntax, the rules, and say, okay, in order for us to create a machine that can talk and use language, we put in the rules, we create the rules. Forget about the Baker's paradox, it's created by us. And they implemented the system, they realized it's too slow. Fast, efficiency. Those are their concerns, the AI research concerns, because they're engineers. So they create a system that can now talk to us, the Siri program or whatever, but they're all being made fast and hardwired into the system. So we do not understand language using AI. You see, I claim AI cannot solve the mind problem because we are always trying to simulate and implement what the psychologist is saying, but the psychologist has no answer. They only have paradox. That's why my claim for AI should be, we must create a solution for the paradox. Now, then, we are really advancing an understanding of the mind. So we have three famous paradoxes: the language, learning. I described learning just now. You have to have a program that cannot be taught or told what to do, and yet able to learn the rules. Now, that is AI contribution. And spatial connection is this. We move around, and psychologists claim that we have a map in the head. We learn a map in our head. But gosh, the map is not precise. The map is inexact, incomplete. Why do we learn an inexact and incomplete map? Why can't we learn an exact map? Now, is it again, you come to the AI people, they say, okay, the robots needs to move around the lab. They need a map. Okay. Well, creating a map is easy. You have a wheel, you just move how many feet forward, another wheel, you combine the two wheels together, you build a map. That's simple mathematics. So they implemented the idea. They realized immediately, oh no, there's serious distortions of the map. Why? Because when the robot moves, there are distortions. So when you move forward 1 feet, it's not 1 feet. It could be 1.5 or 1.2 or 0.9. So with those errors accumulating, the map got distorted. Okay, let's solve that problem. This is what engineers are good at. Like Alan said, they create a problem, they solve the problem, and they focus, and they're very good. They created SLAM, a powerful mathematical solution that could correct the error instantly as it moves. Powerful, but contribute nothing to the mind, because we don't have that map. So your solution is not relevant to the mind theory. So if we understood how the spatial connection, and then the learning, and then the language, we unravel the mystery of the mind, and you will then realize that it's actually quite straightforward why the infants behave the way that they behave.
Relativity is such a core problem in all of this, isn't it? And the fact that as a unique structure within a framework of many structures, our consciousness needs to have relativity. It needs to build its own internal mapping systems. Neuroscientists already have a strong understanding of how the young brain develops, right? And infant brains, child brains, up until young adult, they're very, very inefficient. They're designed to be inefficient. They're designed to capture everything, filter very, very little. Like Albert said, you can't teach them anything, really. They have to teach themselves. All you can really do is you just feed them with information and help them maybe in their decision-making processes. It's only until after adulthood that the brain starts to become more efficient, and the number of synapses that we've constructed as young people actually decay, they degrade, we lose synapses, right? And is that a problem? Actually, no, it's not. It's actually our brain becoming more efficient. It's getting rid of all of the extraneous stuff that we no longer need. We've built our internal mapping systems. And like, when you go on a trip in a car, right? The first time you take a trip, and it seems to take a long time compared with a subsequent trip. Why is that the case? Well, it's because in that first trip, you're capturing as much data as you can about your trip. You're trying to build a relativistic map. All of the signposts, the indicators, the speed, the landmarks that you capture takes a lot of energy, and it takes an apparent longer time. As you do that same trip over and over again, you don't need all those landmarks anymore. You can track your distance, your timing through that same passage by using fewer and fewer landmarks. And so it takes, in terms of a conscious mind, less time to travel the same amount of distance, right? And life is like that too. As we get older, we say that life seems to go that much faster. Well, it doesn't really, because time is fairly constant. Gravitational waves accepted, right? But time is fairly constant. And why does it seem to be that it goes so much faster? Well, it's because we're not needing to track as many events as we pass through it. Right? We're not needing to capture as much data to construct our frameworks, our relativistic models. And so we can get by with fewer. That's one thing. On another aspect, of course, we are better able as adults to learn from other people. We can take suggestions, we can take other people's lessons. And we say, oh, I like that, I'm going to try that. I'll insert that into my mapping system, and I'll see if I can make it fit. Sometimes it works, sometimes it doesn't. And this is an important part, I think, in the learning process. This is, as Albert said, this is something that we haven't been able to do yet. And maybe that's because our models have tended to be too focused on induction and deduction as methods. We haven't, and I'm working on a project at the moment where we're trying to build an intelligent mapping framework around abductive methods, right? And so abduction being the kind of the third model, which hasn't been successfully done yet. And I might have a word with Albert and see how we can incorporate spatial cognition in terms of that mapping framework, because I think that's a part of what we're missing in that. And so how does this lead us to what you're asking then, Aviva, about, this idea of our being an interconnected species, because our relativistic map requires of us to create interpersonal relationships. It's a part of our model building method. I want to wind the clock back a little bit, again, to pre-industrial existence. All right? Because I believe at that time we had, in our cultural frameworks at that time, a strong interconnected relationship between groups of people. We built communities around the existence of these highly connected cultural frameworks, tribalism, if you like. And that was intentionally destroyed in order that an industrial landscape could be built. It was intentionally destroyed.
When you say it was intentionally destroyed, how do you mean that?
Well, because in order for you to have an industrial landscape, you needed to take people out of their tribal existence. You needed to break their relationship with their cultural landscape.
Right. So, but the frame you're offering, that it was broken as a byproduct of the industrial framework rather than as an object by itself, or are you ascribing a more evil conscious intent of breaking the social ties of a tribal structure to deliver people into a more atomized structure where they build greater dependency? That would ascribe almost to cunning and an evil intent. I don't know that you mean it in this way, or you do.
I'm not going to use pejorative terms like evil.
Okay.
Right? But in order for you to create a new cultural landscape, you have to dismember what already exists. In order for people to shift themselves out of a world, a culture, and into a new one, you have to break what already exists.
Or you introduce another option, and in the conflict, that breaks.
Yes, that's right. And so instead of people, for example, earning their living from the labors of themselves in their community, you give them a wage. You give them an economic incentive, and you give them a carrot, or if you like, a golden ring on that eternal carousel to reach out for, right? And yes, it's a deliberate. If you can go back into economic theory and you can look at how this was thought through very consciously. And yes, it was deliberate, and a part of this we see because where we live, Albert and I, we live in a decolonized country, right? The people that lived here previously were colonized, and they were taken out of their cultural environment and they were put into a different environment, and they were not allowed to speak their own language. They were whipped if they spoke their language. They were told that they had to wear certain clothes because this is what civilized people wear, and so on, right? It's conscious and it's deliberate. And I'm not saying that this is unique to this part of the world. It has happened through millennia. Yeah? But where I'm going with this is that we're now in a post-industrial world.
Mm-hmm.
We're now seeing the problems that the technologies that we've created have caused, and many people don't like it. And they want to mitigate or reverse some of the damage that's been caused environmentally, socially, and so on. All right? And we have a technological landscape that has emerged which has allowed for the creation of online tribal existences. There is an interconnectedness that is building up in people, between people, but they're geographically dispersed. The fact that we can do this now gives evidence of that, right? And what we're beginning to see emerge in the social landscape is that there is a new interrelationship that has begun to emerge in communities that weren't able to previously. Now, okay, we can say that there's a bad side of this, and everything always seems to have a good and a bad side, right? And so we talk about things like this echo chamber effect, right? Where algorithms have seemingly pushed groups of people together and they become self-reinforcing. This is the learning thing that Albert was referring to, right? This learning's happening in people. The algorithms are just accelerating the growth of that passage. What we're missing is we're missing the technological advance that allows for the unexpected to happen, right? So what if, for example, we suddenly had at this point in time a Stephen Hawking avatar drop in on our conversation? And we'd all go, wow, that was unexpected. What can this now bring into our conversation? Right? So the algorithms that we have with us are built on an inductive and a deductive framework. In other words, they can only take the data that they've got and they can infer or they can posit. But they can't create the unexpected, create the wholly new. This is something which is uniquely human. The synthetic process. This is the crux.
Okay.
This is where we are now.
So one way that I decipher where we are in the conversation is that there are three overarching inquiries or enigmas or buckets of inquiry, rather. One is to do with the mystery of the mind, the mystery of learning, the mystery of how this thing we call intelligence and we experience as intelligent, how is this arising? How does it work? Can we decode that mystery and build something in technology which is life-affirming and augmenting to the purposes of life? That's so I put two spaces in that bucket one. The second one is truly builds on that, which is the inquiry of so what are and how will technology evolve to make us more intelligent about ourselves, more appreciative of our unique humanity, to support us. And the third inquiry is how will we off-ramp and save ourselves from each other and from the dark side of technology, because part of what you were describing there, it's not really dark side of technology, but what you were describing there, Alan, is how the onset of the Industrial Revolution introduced a new operating system, and that operating system through the arc of time leads to the greed-based, exploitative, extractive paradigm whereby the incentive structure is reversed, where we no longer explore technology through the lens you offer that how can technologies will help us become more intelligent about ourselves and what we can do here. Rather, the a lot of the huge big chunk of the technological research is led by powerful. Essentially, we discovered a bug in the system, okay? It's led by the wrong incentives. That is the bug in the system. Now, what do you do in a piece of technology when you discover a bug in the system? You need to create a solution for the bug. The question is whether we have, as a humanity at large, the capacity to introduce a solution to the bug of the last 200-300 years that includes the industrial, technological, computing revolution and the economic framework that enveloped it, that led us to this point where we have tremendous possibility, but we have some scary trajectories in front of us if we are not able to become more intelligent about how we apply our intelligence. So I'm ready to leave it right there on a cliffhanger and to come back to any of these. I think that is the high altitude mapping that I'd offer, having listened to what you both offered.
I think that there is an intriguing and exciting future in terms of technological advance. I don't know what that's going to look like. I can only trust that our successors have within them the capacity and the means to ensure that whatever spaces that are created are that they are sufficiently well inviting, that people will want to engage, and that they provide the security and the safety that they are treated with respect inside that space that is created.
Well, so let me ask a closing question. Because you just said, you said, I don't know what technology will look like, but you offer some direction, and you may have in part answered my question. I will frame it nevertheless and let both of you offer a brief comment to that. Suppose you were made a benevolent emperor of the world for an hour, and you were given the powers to issue one directive, which is to guide technological development into the future. What do you include in your brief? How do you shape your benevolent direction to the next decade or 2 or 3 of technological development and evolution? What's your message? What's your brief? What's your direction?
For me, it's straightforward. Focus on the intelligence bit and not the artificial bit more. Unravel the mystery of the mind. Is a beautiful system, the mind. And we have the power to do that.
It is. It's the most marvelous thing. And what I would write into the brief is to ensure that humanity is not forgotten in the creation of it.
Thank you. Thank you very much.
Thank you.
Thank you, Aviv. Thank you, Albert.
Thank you.